All right. Not exactly standing room only. It is lunchtime, is it not? All right, well, thank you for coming. This talk is the technical debt trap. Throughout this, I'm going to ask a few questions of the audience. And I am looking for some exchange, just a little bit of question and answer type stuff. So, just as a warning, right? For those of you that don't know me, I am Doc Norton. I am the co-founder and CEO of a consultancy called CTO2. And we do process and leadership coaching for companies, mostly in the US, but certainly around the world. This talk is technical debt. You can use that hashtag if you want. Of course, we're at NDC Sydney. And I am Doc on Dev. And I'm Doc on Dev everywhere, just all the things whack Doc on Dev. I got lucky enough to get almost all of them. And the ones I don't have don't matter, right? So I said I was going to look for some interaction with the audience, and I'm going to start off with that. First thing I want to know from folks here, what is technical debt? When you think about that, what is your definition, right? Anybody have anything that comes to mind for them? Unsupported code? Code that's no longer fit for purpose. Any others?
Things that you should be doing but not doing, and then you leave it till like 5 years later but still not doing.
Things you should have done but didn't, and then kind of deferred, and 5 years later you still haven't done it, and yeah. So how many of you know where the actual phrase technical debt came from? Who coined that phrase? Ward Cunningham. He did, yes. So what Ward tells us, by the way, if you don't know who Ward is, go study that now. All of the things that you know and need to know trace back to Ward, right? Basically, everything we do today didn't exist until Ward came along. But technical debt, in 1992 at UPSLA, Ward published a white paper. And in that paper, he was talking about his experience with a client and some interactions that he had with them. And he had told the client, look, shipping first-time code, it's like going into debt, right? And a little debt actually speeds development. And as long as it's properly paid back with a rewrite, we're OK. But the danger occurs when the debt isn't repaid. Every minute we spend on not quite right code counts as interest on that debt. Now, I've known Ward for a few years now, and one of the things I find about Ward is that he's very deliberate with his words, but oftentimes it's a little subtle. People miss what it is that he's actually saying. So I want to zoom in on this particular set of words, this phrase that Ward uses, right? The danger occurs when the debt's not repaid. Just honing on a couple of words. First of all, he chooses the word danger. He doesn't say the challenge, the hurdle, the concern. He actually uses the word danger. Danger, in my mind, is fight or flight type of stuff, right? This is something we should be seriously concerned about, not just, there's a problem here. The other thing is, he tells us every minute that we have this debt, there is danger. So it's not every year or quarter or release, iteration. Every single minute that we have this debt, there is danger. And what is this debt? It's code that's not quite right. Not messy or shoddy or sloppy or crappy or thrown together. It's code that's just a little off, not quite right. And every minute we have that, we have danger. But ultimately, technical debt is good. Why is that? Well, with Ward's definition, technical debt is actually a strategic decision, right? What we're doing is we're making a decision to do something with the implementation that allows us to actually get code out faster, to get quick feedback from the market, and maybe to correct our design, to correct the implementation as we learn. So kind of talking about MVP type stuff back in 1992, right? Sometimes technical debt occurs as an indication of learning. So we didn't do it on purpose. But what happened was when we released this thing to the public, when the customers actually interacted with it, we then learned that we needed something else, right? That our implementation doesn't actually match what we now know to be the requirements. Now, technical debt is actually just a metaphor, right? In this case, it's a metaphor for here be danger. And the reason that Ward actually chose technical debt, among any other number of things that he could have chosen, was that customer, he was actually writing a YCash portfolio management system. So his customer was in the financial sector. And he chose wording that they could relate to, right? What they wanted to know was, why is it that your team is going back and working on code that's already done? And he was explaining basically incremental and iterative development and the cost of having your code be out of sync with your now known requirements. But he chose technical debt because that's what resonated with his particular customer. And I wonder often if Ward had been working for a medical institution, or if he had been working for an arboretum or something else, if we'd have a better, a more rich metaphor where we could actually talk about care and feeding, health, et cetera, versus debt, right? But ultimately, he chose this metaphor because it actually made sense to his customer. And in that regard, metaphors absolutely rock, right? We reason by analogy. So if you and I are talking about something, it's a domain that I understand, but perhaps you don't. Through metaphors, I can explain what it is that I mean. I'm talking about this particular subject. I take this replacement object that we both know, and I compare them, right? And now we have something of a shared understanding. If I tell you that code that doesn't quite match the implementation is like having debt, and you're in the financial field in the 80s and 90s, and you understand debt as a decision, but typically a risk, that's a decent metaphor. But sometimes, when we're dealing with metaphors, what happens is we almost forget entirely about the actual subject, and we continue to debate the properties of the replacement object as if that were the real thing, right? And I call this metamorphosis. This is fundamentally when metaphors go wrong. How many of you have been in a conversation where someone says something along the lines of, you want us to fix this code and keep everything live in production. It's like you want us to change the tires while we're driving the car down the road. And 10 minutes later, you're actually arguing about the possibility of a tow truck that can lift the car off the ground and maintain speed. And right, you're talking about something completely different from what was the actual subject, right? This, in my opinion, is what happened with technical debt. It underwent metamorphosis. People heard the phrase, didn't know exactly what was meant by it, but went, oh, well, I know what debt is. Let me explain to you, therefore, what technical debt is. And over time, we started talking about things like short-term debt and long-term debt and high risk and low risk and loan sharks and fraudulence and the inadvertent reckless debt in the third quadrant, which in fact is a thing that we will look at a little bit here, right? And this became so common in the industry that our leaders started to refer to technical debt in the same way, in this quick and dirty, cutting corners, hacking it in, sloppy, right? And eventually, this led to arguments about what is or isn't debt, et cetera. And Martin Fowler came out with the technical debt quadrant. How many are familiar with the technical debt quadrant? All right, we got one. So we'll walk through it fairly quickly. And fundamentally, Fowler's argument was, look, These discussions about what is or isn't debt aren't valuable. What we should be talking about is where did it come from and how do we remediate it, right? So he introduced the quadrant. And in this quadrant, he says debt basically is either the result of prudent behavior or reckless behavior, right? So either we are behaving professionally, we're behaving well, or we're behaving unprofessionally. And we may be doing that deliberately or inadvertently, right? So we may get debt on purpose. Prudent and deliberate, we actually made a decision to go with a lesser implementation, right? Let's walk through this. Inadvertent and reckless would be things like you don't know about good architecture, right? You don't know about good design. So you actually aren't sure what it is that you're doing, right? Deliberate and reckless, on the other hand, is you've intentionally decided to skip good practices, right? So we don't have time for design or whatever that might be, right? Prudent and inadvertent, and this one actually was difficult for me to understand for a while because I was thinking like, how can you be accidentally prudent? But that's not really what this means. What this means is that we behaved prudently and later discovered that we had debt, right? So we wrote good code, we tested it well, we put it out there, and then we came to learn that that's not what the actual business needed, that's not what our customers needed. And according to Fowler, prudent and deliberate is shipping now and dealing with consequences, right? So he kind of tries to break it down into like, oh, there's different types of debt. There's this stuff that's prudent. There's this stuff that's reckless and deliberate and inadvertent. And so he's actually advocating for this expansion, if you will, of the technical debt metaphor, which kind of had already happened in our industry. So now, years later, it's 2009, and Ward kind of raises his head back up and looks around and goes, what the hell have you done to my metaphor? He says, an awful lot of you are explaining this metaphor and confusing it with the idea that you could write code poorly with the intent of cleaning it up later, doing a better job later. You have confused the debt metaphor with the idea that you could write code poorly. But the ability to pay back debt depends on you writing code that is clean enough that you can refactor it as you come to understand the requirements. Clean enough to be able to refactor. So what is to refactor code? What's refactoring? Moving code around, okay. Any other? Simplifying. When we are refactoring code, are we changing the behavior? A typical classic definition of refactoring, we are changing the implementation without changing the behavior, right? So I might extract a new method. I might, in fact, create an entire new class. But from the actual behavior, from a user experience, et cetera, nothing has changed. I have manipulated the internal functionality of this code, of this class, of this method, but it still behaves exactly the same, still produces the exact same output. How would I know, having made a change to the code, it still behaves exactly the same? How can I guarantee that? I would have tests. Yes, I would have tests. So interestingly enough, what's happened with this metaphor over time is it has come to mean any kind of code that we don't want to have to deal with. It has come to mean crappy code. But what it actually meant was clean, well-composed code. The original definition of technical debt, clean code is a prerequisite for technical debt. You have to have clean code, and you have to have test coverage in order for you to have technical debt. So his last kind of statement on this, on Twitter, he said, look, dirty code is to technical debt, as a pawnbroker is to financial debt. You guys want to go with this metaphor? Great, let's go with it. Don't think you're ever going to get your code back. So the question still in my mind is, do we or do we not have technical debt? right? How do we know that we've got technical debt versus something else? So I've got a bit of a heuristic that I kind of use to say, yes, it is or is not technical debt, right? One, is the code clean? Is it tested? Is there a learning objective or event? So did we do this thing on purpose? We did not implement the ability to bundle things in the cart because we wanted to learn if people were even going to buy these items, right? Or was there an event? We implemented it this way and then learned later that the market actually didn't care for that particular implementation, right? Is there a plan for payback? And when I say a plan for payback, I don't mean like, well, someday we'll get around to it, maybe, kind of, sort of. I mean, have we actually talked about, okay, there was this learning event, and now that we've actually learned this, here's what we're going to do, and when we think it's going to happen in terms of priority of all of our other work. And is the business truly informed? This is a very difficult one. Oftentimes, developers are like, yeah, the business is informed because I told them if we keep doing this, it's going to be really bad. And I mean, do they really understand what it is that's going on? Were they a part of the actual decision? If you look at this list, and you can say no to even one of them, then you don't actually have technical debt. So what then do you suppose you have? You got a mess, right? And this isn't a bad definition for what we have, right? Disorderly accumulation, state of embarrassing confusion, right? But I found a better one. Cruft. It's an unpleasant substance. It's the result of shoddy construction, or according to the dictionary, it is redundant, old, or improperly written code. So cruft is actually the proper definition of much of what we actually call technical debt these days, right? Now, I've given this talk a number of times. I've had people that say to me, well, look, that's all well and good, Doc. Like, I hear you have an opinion. But really, it's just a matter of semantics, right? I don't think it is. It's not just semantics. And here's the reason. If we agree that technical debt is good, and we also agree that quick and dirty is technical debt, by the transitive property of technical debt, quick and dirty is good. And I cannot abide by that, right? I've never seen a project that was done quick and dirty and actually sustained. At some point, we had to call for the grand rewrite. At some point, we got ourselves into serious trouble with this thing, right? I want to go back for a second here to this technical debt quadrant, because it was something that, yeah?
So you talk about at some point we go through rewrite. Isn't that a good thing in a way?
It could be. So the question was, he said, I said, at some point we go through a rewrite. Isn't that a good thing? It could be, right? But I've also seen systems where an actual complete overhaul rewrite is never necessary, right? That we're able to iterate on that design over time and able to actually, extend it, flex it, retire pieces of it. And at no point did we have to actually freeze code and go for parity match to completely rewrite the thing because it became too arduous to actually, work on the existing code base. So I want to go back to this technical debt quadrant because when it came out, so it was 2009 that Fowler actually wrote that article. And it was interesting. I'm not going to pretend by any means that I had a whole lot to do with any of this crap. But I had recently written an article that messy code is not technical debt. Shortly after that, Uncle Bob wrote a very similar article. And shortly after that, Fowler came out with the technical debt quadrant. And shortly after that, Ward came out and said, shut the hell up, this is what I meant. But when Fowler came out with the quadrant, I was actually sitting next to him at ThoughtWorks. And we talked about it for a little while. And it bothered me from the very beginning. But back then, I couldn't articulate what it was about it that it just didn't set right. So over time, I've kind of figured out a few of these things. One, the prudent and deliberate, right? We must ship now and deal with consequences. That actually doesn't sound prudent to me. It certainly sounds deliberate, but it doesn't sound prudent. And I would much prefer that it actually said, let's deploy and gather more information, right? That sounds more like prudent, deliberate behavior to me. But that's a minor thing. What really bothered me about this was the second half, kind of the reckless half of the quadrant. It just didn't set well with me. And it took me a while to figure out why. And the way that I figured it out was I started thinking about, okay, let's take this metaphor, let's take this concept, and let's look at it in other industries, in other fields, and does it still make sense? So technical debt in some other fields. Construction. Can you imagine if you paid $250,000, $300,000 for this thing to be built, and the general contractor says to you, well, you know what, we incurred some structural debt in order to meet your deadline, right? We should probably discuss that debt and set a plan for paying it back in the future. Automotive, right? We incurred mechanical debt to stay in budget. Medical. Well, we incurred some health debt along the way, right? You see, it's like we paid for the surgery with a credit card instead of a home equity loan. Right? When we look at this in other fields, it doesn't resonate the same way. It doesn't make sense. You might say, oh, well, it's because it's the physical world versus the digital world. I think there's more to it than that. So if we look at these things, the two on your right, those are reckless and deliberate behaviors, right? In both cases, maybe the building settled, but I've looked at that photo over and over and over again, and there are not stress marks in any of the bricks. They put the damn windows in crooked, right? And clearly the vehicle, that wasn't, they finished it and went, whoops, they knew they were doing that, right? So that's reckless and deliberate work. And we're gonna give the one on the left the benefit of the doubt, and we're gonna say that that's reckless and inadvertent. Right? They didn't mean to do it, but it's still not good stuff. So let's map that back to our quadrant. That's what those are, right? Reckless, deliberate, reckless, and inadvertent. Are there other names for that kind of behavior? What else could we call that? In my opinion, we're talking about irresponsible behavior and incompetence. So we're on the reckless end. We're talking about irresponsible and incompetent behavior. And wrapping that in the warmth of the technical debt metaphor is a pretty risky thing to do. This prudent behavior actually is the only behavior that results in true technical debt. So it's kind of heavy, right? Let's lighten it up a little bit. Let's play a game. Who wants to play a game? All right. So the game is called Cruft or Debt. All right? So we're going to go through 3 rounds. They will get progressively harder. And all I need from you is to tell me if the code example is cruft or debt. Ready for round 1? Is that cruft or is that debt? That's got to be cruft, right? You don't even have to be a programmer and you know that something's wrong with this. So let's take a look at it, and we'll go through this fairly quickly. First of all, let's just collapse all those curlies down so we can actually read it. There, so now it's so much better, right? All right, so basically what we're doing is we're iterating through like every freaking table and every column and every row and every, that stuff's unnecessary, right? So let's assume that we don't have multiple tables in the data set. Let's assume we don't have to actually iterate through all of those columns, right? And that we know that we're looking for, if you read through this, we're looking for an agent ID and we're looking for a queue name. So let's just eliminate all of that overhead and pretend that we actually know how to interact with the database. So it gets a little bit better, right? And now what I'm going to do, I'm not going to show you the code for this, but we're going to actually just introduce some abstractions. I'm going to create some classes that receive data sets and return collections of objects. Basically what I'm doing is I'm going to introduce an ORM, which any one of us would typically use these days, right? Or we wouldn't, right? But I'm going to get rid of some of this stuff, right? Okay, so now it's getting better. Like we're actually getting to the point where we almost can read this and figure out what the hell it is that it's doing. And if we actually go through this, it looks as if what we're doing is we're looking at this agent and we're determining if it actually has these skills recorded in a particular table. If so, then we're actually calling this set agent Q skill and we're returning back this record set that fundamentally says, here's all of the skills that this agent has, right? So this code shouldn't even exist. This should be a view in the database. You shouldn't have to do any of this. So all of that was completely unnecessary code. Didn't need to exist at all. You could have done all of that with basically 2 lines of code, a simple join in the database itself. All right, so the next one, cruft or debt. So round 2. What do you think on this one? Cruft? Do I have any debtors? Cruft. Why is that? Feels like it's crufty. Yeah. So here's the thing about this, right? If we look at this, we have no idea what class this is in. We don't have any idea what method this is in, right? So it might be a little bit difficult to say what exactly is it that this is doing. And I can read this. I can see that I'm looking to see if the customer state is Alabama, if their type is a general agent, if they've got a revenue over $100,000, right? I can read all of that. So it's readable. But I have no idea what any of that means. I don't know what this code is actually doing, right? From a business perspective, I have no idea. Lucky for us, there is a universal fix for that. Add a comment. I now know what this code does, right? Fixed, no longer cruft. Now, if we can do this, right? There's another thing about this. We know that this code does not in the customer class, right? And how do we know that? Customer dot, customer dot, customer dot, customer dot, right? What are we doing? We're interrogating the snot out of our customer. We're asking it a bunch of questions in order to make a decision. This seems a little overly intimate, right? There might be a little bit of feature envy going on here. There's something else. This probably belongs in the customer class itself. We can actually ask the customer, are you federally regulated? And it should know that. And in moving it into the customer, my guess is that this code would actually get much easier to read, would be much cleaner. And that's actually, I think, what we want to do with it, right? Now, easily readable. All right, last one, last round. Bonus points to anybody who gets the joke hidden in here. Little Monty Python for you, right? So is this cruft or is this debt? It's hard to say, isn't it? That's actually the answer. The answer is it depends, right? This comes down to a matter of strictly opinion, right? What do we have here? We've got a switch statement with 3 options to it, right? Fundamentally, this is a nested if. We've made it a switch so it looks a little bit better. So we have relatively high cyclomatic complexity for this particular method, right? That may be a concern for us. We may not want that complexity in the code. High cyclomatic complexity directly correlates to high bug count. We know that. But the fix is, polymorphism, right? Which means that now we've got base classes, we've got inheritance, et cetera, and leaving out some of the details, that fix looks a lot more like this. Now I've got 3 different places I have to go look to figure out how this actually works, et cetera, et cetera. The point here being, at some point, that case statement, whether it's 3, 7, 142, at some point, that case statement has too many options in it for us to consider this to be a good piece of code anymore, and we need to fix it using this technique, right? Is that in the first else? Is that in the second else? That depends on what your team decides on, what your team agrees on, what your organization agrees on, right? If you listen to Uncle Bob, then you should have, done it right away, right? But that's not always practical. So, cruft. It's a bad decision, right? One, we're professional developers. This is what we do, right? We get paid to do this, and the expectation is that we are professionals and that we're doing it well. We get paid pretty well for what it is that we do. And you're going to create unintentional cruft. You can't help it. It's unintentional, right? You will come to realize 6 months from now that the guy that wrote this code was a complete idiot, and then you'll realize it was you, right? And you're going to have to clean up that existing cruft. It's going to get in your way. So the trap becomes when we actually start off writing crufty code. Because what we've done is we've set a precedent for speed over quality, right? We've cut a few corners here and there to get something out the door just a little bit faster in the short term. And we've set this expectation that this is how fast we can move. And many of us work in environments where we're agile of some sort, right? We're agile-ish. And what's one of the magic promises of agility? One of the reasons that management wants the Agile installed is because they read a book, and in that book it said, after 3 weeks, your velocity will go up. It doesn't say how, but it says it'll happen. So there's this expectation that we're going to be getting faster as we get better, as we come together as a team, right? But the cruft starts to slow us down. So our only option is to write more cruft in order to keep up, and in order to meet those expectations. And eventually what happens is we have to ask permission to do our job correctly. Now, I talked about this a little bit earlier. This tends to mask itself, right? This tends to be, we have to call for the grand rewrite. Well, Java 8, blah, 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 right? And it's usually, we're kind of blowing smoke. The truth of the matter is, if we had done this well, we could upgrade to Java 8 without any problems, but because it's poorly written, it's really hard, so it's just easier to redo the whole thing, right? So how do we manage cruft? Well, one of the common things I see is actually a failing strategy, and that is this idea of a cleaning sprint. Right? Now, how many of you work in organizations or have worked in organizations that do this? So we go along for a while, and then we have a hardening or whatever, some period where we're going to clean all the things, right? So we actually schedule an iteration for cleaning up the code. And what ends up happening is we're deferring quality to the cleaning sprint. So we can move as fast as we want right now, and then we can clean it up a little bit later, right? And we're focused on speed, velocity at all other times. Well, the study's a little old, but study's been done. And what they found was this. So we got 3 lines on this 3 colored lines on this graph, right? The top one, black, is basically an application with no refactoring, no cleaning. And what we're looking at is, over time, the actual cost of change in the application. So we can see that over time it goes up, right? And they're showing at 9 years, it's right at this inflection point where around 11 years, it just goes straight up in the air, right? So we've gotten to a point where it doesn't matter how hard you try, you basically can't add any new features because the code base is just too hard to deal with. The purple line is the cost of change for organizations that do these cleaning sprints. So we can see that every once in a while they actually go through and they clean up the code, right? But the rest of the time, they're thundering along at a high pace. There's an interesting phenomena that I see in these types of organizations. At the end of every single cleaning iteration, at the end of every single cleaning sprint, what does the next sprint look like? it is at least 50% more loaded than it should be, because we just spent 2 weeks, 4 weeks delivering no value, and the business is in a panic, right? So we come right out of the gate cutting all of the corners. And what ends up happening eventually is we just can't keep up. So then the green one is if we're refactoring continuously. And we can see that eventually off in the distance somewhere, just because the code base keeps getting larger and larger, it does get more expensive, harder to actually work on. And the reason that I actually point out that this is an old study is this is in years. So they're basically showing that at like 10 years, the code base will become too difficult to deal with. That's no longer true today. The rate of change is accelerating. The amount of time. Think about for those of you that have been in the field for a while, right? So I've been doing this for 30 years. There was a period where I started on, Java 4, whatever, right? And I could write an entire application, and we could go a decade and upgrade it once or twice, whatever, and introduce no new technologies. Today, we're constantly changing. We're introducing new stuff, right? You're thinking, you're introducing a new technique on the front end. You're introducing new tiers in the middle. It's the world that we're in is much more complicated, much more complex, and the rate of change is accelerating. So, what's wrong with this graph is now it's at about year 4. Without any refactorings, that you get yourself into the point where we can't make any more changes. So all right, if that's a losing strategy, what's the winning strategy? The only one that I've actually found is to just constantly clean, right? Don't make an intentional mess. Monitor your technical debt, and I'm using the air quotes there because what we're really monitoring is our cruft, but the entire industry calls it technical debt. Follow the Boy Scout rule. Who knows what that is? The States, everybody knows what it is. What is it?
Leave the campground tighter than you found it.
Yes, leave the campground tidier than you found it. Leave the code base better than you found it, right? Over time, that starts to add up. So you go in, you do your thing, you add the new feature, you add the new functionality, you do that well, and while you're in there, you go, you know what? I could abstract this out. Or, gee, that variable name's not very clear. Maybe we shouldn't have these magic numbers in here. Right? Just something small. But if all of us do that over time, the code base gets better. And what areas of the code base get better? The areas that we work in the most often improve the most. So our day-to-day lives get easier, right? So you may have some area of the code that nobody ever touches, and it's still crufty and nasty and a little bit scary. That's fine if no one's ever touching it, right? And remember that quality is your responsibility, and don't ask permission to do your job correctly, right? We as developers need to stop abdicating our responsibility to the business, right? The business wanted me to do it faster. They're always going to ask you to do it faster. The expectation is that you are going to behave professionally, right? I want my plumber to cost less when he comes in. I want the job to be done faster. But I don't expect that the pipes are going to start leaking, 2 weeks later, and he's going to charge me again or explain that it was my fault because I didn't give him enough time, right? I expect him to be a professional. We are professionals. This is what we should be doing. Monitoring cruft. How do we do that? Code coverage, code complexity, coupling, and maintainability. So there are a number of static analysis tools out there for whatever platform you're on, right? A couple of things. I would say monitor more than one metric. I like coverage. I like measuring complexity. And complexity can be measured in a number of different ways. So there's cyclomatic complexity, there's ABC complexity, which basically are they're similar. It is a way of determining the number of logic branches in your code. And there's a direct correlation between cyclomatic complexity or ABC complexity and bug count. The folks at Code Climate, they have been running analysis against literally thousands of code bases for several years. They started off in the Ruby space and now do Java and JavaScript and a number of different things, right? So they have analysis against millions and millions and millions of lines of code across hundreds of thousands of projects. And I was talking with their CEO a couple of months ago, and he said that they've actually dropped cyclomatic complexity and ABC complexity in exchange for lines of code. There's a direct correlation between the number of lines of code you have and the number of bugs you have in the application. And it's much faster to count lines of code than it is to actually run through an entire mathematical calculation that fundamentally doesn't tell you anything other than lines of code, right? And if you think about it logically, the more code you have, clearly, the more bugs you have. So when he first told me this, I laughed my ass off because he said, well, one of the metrics that we think is really important is lines of code. And I was like, whoa, what do you mean? That's a metric we dropped in the 70s because we learned it wasn't a good idea. But that's how they actually determine complexity. Coupling, efferent and afferent, but if you don't have that, just the fact that there's coupling in the application, right? What's dependent on what? What are you dependent upon? What's dependent upon you, right? And then maintainability. How many of you are in the .NET space? I think this is a fairly .NET heavy, right? So they still have the maintainability index, right? Yeah. So the maintainability index is a single number that applies to the code base that basically takes a few different static analysis metrics and aggregates them together, and then gives you a single number that says the code is this maintainable on a scale of like 0 to 99. I like combinations because if you look at any one of these in isolation, it can be gamed, right? Not that we as developers would do that intentionally, but any metric creates a change in behavior, whether you want it to or not. And I've got a whole talk on that. But what I found is with coverage, complexity, and coupling, I challenge you to deliberately game those metrics. The only way you can do it is to accidentally write better code. So that combination helps us, right? But very important, monitor the trends, not the points. Do not worry about, do we have 87% coverage, and if we don't, fail the build, right? Don't worry about, is the complexity at this exact number or that exact number? What you need to concern yourself with is it trending in the direction that we expect? Is it getting better? Is it staying the same? Is it getting worse? There are times when you will make the decision that the quality should go down. We need to hit this deadline. We've got to get this done. We don't do this, we don't get the 10 million. We don't get the 10 million, we don't have jobs. But monitoring those trends and understanding it is going down, we expected it to go down, allows us to also then have the conversation about, okay, now it needs to go back up, right? As long as it's trending the way you expect it to, I think you're in pretty good shape. So I want to make sure we have time for question and answer. I think we'll have about 15 minutes left. So I'm just going to do a quick review here, right? So technical debt, it is a strategic design decision. It actually requires the business to be informed, and it includes a payback plan. Cruft happens. It needs to be monitored and cleaned, and it is not technical debt. And the last point that I want to drive home, never ask permission to do your job correctly. Thank you. I'm going to advance the slide one more time just so you guys have this, and then we can do question and answer. So, all right. If you send an email to cto2@sendyourslides.com with the subject line technical debt, I will auto-reply with a version of this talk, as well as links to all of the research behind this. So the reports that I showed, links towards videos, the OOPSLA paper, et cetera, et cetera, et cetera. So thoughts, questions, feel free to call bullshit.
So on the slides before, I think when you have the craft and you have like code coverage and so on and so on, isn't that means the craft becomes a technical debt, because then you have code coverage, you actually be able to refactor and pay that back.
So if we have coverage, then it becomes technical debt, right? By the actual definition. Yeah, I suppose that could be true, right? If what we're dealing with is we have clean code, it is well covered, and we just know that we need to actually do some refactoring, or we need to make some adjustments so that our implementation matches our known requirements. Yes, but you may have 27% coverage, right? You might know that this area of the code is in very bad shape, that it's actually crufty. It may turn out that from a business perspective and strategically, it doesn't make any sense to change that, right? Oftentimes I see this where you go into an organization and there's a certain core piece of the code that just works. It just does its job. No one's touched it in 10 years. When you get in there, it's ugly and it's scary and no one's really sure how it works or what it's doing. But as long as you don't have to touch it, you can leave it, right? It's still cruft, but it's safe-ish. We got a guy in the back too.
Thank you. I've worked in a few organisations where we've tried to do the technical debt sprint.
Yeah.
And what I've observed is it never happens. Teams get really invested in building product, and we'll just do one more feature sprint. We'll just do one more feature sprint. We'll do the technical debt sprint. We'll do 2 technical debt sprints. And what starts out as teams spending like a quarter of their time all up paying down technical debt or dealing with craft or whatever it is, it ends up being absolutely no time. Just wondered if you had any kind of observations on that.
So that's part of the reason that, when I talk about the metrics, right, what I want us to do with those is actually fold those into conversations with the business. So we're looking at them in sprint reviews. We're looking at them in retrospectives. We're posting them very publicly within the team room, if at all possible, right? So they become a part of the broader conversation. Because what I really want is I want everyone involved in the decision to incur this debt or to generate this cruft, right? Having folks that are driving product forward understand the effects of these decisions, the outcomes, right? So if we can consistently see iteration after iteration after iteration that the code quality is getting worse and worse and worse, it ideally leads to a reasonable conversation. The other thing I look at is cycle times and lead times. And I've got another talk that's just on metrics alone. Sometimes in organizations I'll actually show them, look, I've done these studies in other organizations, and what we are actually finding is the higher the code coverage, the lower the cycle time. In other words, clean code actually leads to faster delivery. The problem is we're never making that investment, so we're not ever seeing that return. And ideally, that leads to a better conversation about, all right, let's start cleaning this up, and it's going to take some time, but you're going to actually see, better throughput in the long run. So yeah, it's getting all of that information in front of everyone involved, especially the business. He had one over there.
I hear a lot of stuff around chaos engineering, where they sort of, like on the quadrant kind of thing, it's kind of intentional kind of
Chaos
thing.
engineering.
Yeah.
Are we talking about, oh, come on. Say it again? Oh, Chaos Monkey.
No, more. Well, no, this was more about the fact that they don't actually know. Sometimes we can get into a mindset where we need to know the domain, black and white know the domain,
right?
In order to structure our code efficiently.
Well, so that's an interesting argument, right? So the idea that in order to structure the code well, you need to actually know the domain, at a very deep level, and I'm not sure that's actually valid, right? So I'm trying to think of the gentleman's name, and I can't, and I really wish that I could. But 2U is a company out of New York. And they are involved in the education space, which is not really material here, but I'm just kind of trying to get Synapse to fire. They have been building a microservices ecosystem where anyone on the team can build a very discrete service and add it to the infrastructure, and it either does its job or it doesn't. And it either gets used or it doesn't, and it's a very interesting approach, right? So they have absolutely no idea what this end thing is going to look like, but they're writing code in teeny tiny discrete, functionality, and then basically releasing it into this ecosystem. But all of it is well composed, well put together. I will admit, though, that they are not doing any kind of unit testing because the pieces are so small that it seems, that there isn't a point to it, right? This service itself is so tiny. The testing is, does the ecosystem accept it or not? But I think if we're thinking about the composition of the code, and we're designing it well so that it is actually extensible, that it's malleable, that we can easily change it over time. That's all kind of part of this agility, right? That as we learn, we can more easily move in a particular direction. So the idea of emergent designs, emergent architecture, all comes from this delivering small pieces incrementally. And I don't know as we really need to know the whole picture. Right? We kind of learn as we go along, and designing and delivering in this way allows us to do that. I was the lead on the rewrite of Southwest.com, and there were many, many times where that's exactly what we did. We were not sure what this thing was going to look like, but we had some general idea, and we just did small pieces and kept moving along. And the advantages there were things like new federal regulations came in, and we were able to respond to them very, very quickly because we had written it in a very malleable way and because it was well tested and all that. So I don't know if that actually addresses what you're... All right. Other thoughts? Well, cool. Thank you, everybody. I'm around if anybody wants to chat more.